Triangles using the law of sines. What is it? Law of sines is the relationship between the sides and the angles in triangles. Why? Can help you find the missing length of a triangle. Interesting fact, the hummingbird can hover, fly forwards, backwards, and even upside down. Now here we have the law of sines, where we have the sine of angle A over the side of A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. Now let's discuss how to use this formula with example 1. Before we do that, let's read the steps. Step 1, label the triangle. Step 2, set up the ratio. Step 3, solve for one variable. Now let's read the question. Solve for triangle ABC. Now let's take a look at the image that they gave us. They gave us three measurements: 32 degrees, 35 degrees, and 10. Now, is this enough information to solve for the triangle? Well, let's find out. Now we're going to go ahead and set up the ratio because the triangle is already labeled for us. Sometimes the triangles aren't labeled, and you should label it so you don't get confused. Now, how do we set up this ratio? Well, we take one angle, for instance 32 degrees, and go straight across from it and write it over the side length. In this case, we have sine of 32 degrees over 10. And now we continue down the road. In this case, we go to angle B, and since we don't have angle B, we just write sine of B over the side length of B. And next, we're going to take a look at the 35 degrees and write sine of 35 degrees over our side. Since we don't have it, we write C. And that is how we write the ratios. Now, does it matter where we start with A, B, or C? No. But as long as you keep it the same throughout, you'll be golden. Now let's take a look at the image once again. They give us two angles, 32 degrees and 35 degrees. And that means we can find the third angle by subtracting 180 degrees minus the two angles that they give you. So in this case, angle B is equal to 180 degrees minus 32 degrees minus 35 degrees. And the result of that is angle B is equal to 113 degrees. So we've already added that degree on the image. We've also added the 113 degrees in our ratio. Now we're going to go ahead and solve for side B. Why are we doing side B first? Because it is next to the blue ratio and we already know both of those variables. And so we're going to go ahead and start with that one. So we have sine of 32 degrees over 10 is equal to sine of 113 degrees over B. And now we're going to do the butterfly method of multiplication to help us with the solving for side B. And now we're going to multiply this oval first, sine of 32 degrees times B, because that is the oval with the variable. And now we're going to multiply the other oval, 10 times sine of 113 degrees. And now let's go ahead and put the other side back. Now we have B times sine of 32 degrees is equal to 10 times sine of 113 degrees. We need to solve for B, so we need to get B by itself. In order to do that, we need to do the inverse operation of multiplication, and that is division. So we're going to divide the left side by sine of 32 degrees, and when that happens, those numbers cancel because the result is 1. And since we divided sine of 32 degrees on the left-hand side, we now need to do it to the right-hand side. And now, let's write down what we have so far. We have B is equal to 10 times sine of 113 degrees over sine of 32 degrees. And that is B. But most of the time, your teachers or your textbook will ask you to solve for B or write it down as a number, and B is equal to 17.37. As we can see, if we take a look at the image, we've added 17.37 for B. Now we're going to go ahead and solve for side C. We're not going to use side B because it's rounded. And using rounded answers to find another answer is evil, especially when you have to type in your answer online and when those answers need to be specific. So let's go ahead and write down our ratio or our equation that we're going to use to solve for side C. Once again, we're going to use our blue ratio, sine of 32 degrees over 10 is equal to the sine of 35 degrees over C. Now we're going to go ahead and use the butterfly method to solve for C. we're going to take a look at just the oval with the variable in it. So we're going to multiply c times sine of 32 degrees, and we're going to set that equal to the other oval. So now we're going to multiply 10 times sine of 35 degrees. Let's bring back the other side. Right now we have c times sine of 32 degrees is equal to 10 times sine of 35 degrees. We don't have c by itself, so in order to do that, we need to do the inverse of multiplication, and that is divide. So we're going to divide the left side by sine of 32 degrees. So those numbers cancel because the result is 1. Since we divided on the left-hand side, we're going to divide on the right-hand side. And now let's write down what we have so far. We have c is equal to 10 times sine of 35 degrees over sine of 32 degrees. And that is c, but sometimes they want you to write it as a decimal, and c is equal to 10.82. If you take a look at our image, we've added our value there as well. And so we found the 3 missing variables for example 1. Now, when can we use the law of sines? Let's find out. We can use it in any of these scenarios. When we have an angle-angle side triangle, that gives us one solution, or we can use it when we have an angle-side angle triangle, that also gives us one solution. But when we have a side-side angle triangle, that's when we have to be worried, because it can give us no solution, one solution, or two solutions. And that is called the ambiguous case. And we'll discuss that in a future video. And now it is your turn, so go ahead and pause the video so you can take your time to answer this question, and I will show you the results in 3, 2, and 1. Here they are. If you got them correct, well done. If not, there's always tomorrow.